Hello everybody, I'm Carolin and I want to present you LogChunks, a dataset that we created to analyze build logs better. In continuous integration, when a build fails, what we are looking for is often why did the build fail. For that we can look into the build log and it will, in this example, tell us which was the test that failed. However, a build log also contains huge amounts of very detailed further information about what happened in the build. To make use of the information within the build log, we have to retrieve the parts that are actually relevant to us. In this example, that are the two lines that describe the failing test. And this is what we call a chunk, so a substring of a build log that describes a specific information. Searching for these chunks is like searching for a needle in the haystack, because the logs can be very verbose or very long. And because of that, in the last years, several automated techniques have been proposed that are used to analyze build logs. Though what we are currently missing is a dataset to train these techniques and compare them against each other. And that's why we created LogChunks. LogChunks encompasses about 800 build logs from 80 different GitHub repositories that spread a range of 29 different programming languages. And that is because we wanted to show that these techniques can operate on a wide variety of projects and build tools. For each of the build logs, we manually labeled the chunk that describes why the build failed. So for example, the failing test or the linter warning. We also externally validated these chunks by surveying the developers who originally triggered the build. And we asked them, is this part of the log really describing why the build failed? We got answers for about 25% of the logs in our dataset, and 91% of these answers said, yes, you are correct, this is actually why the build failed. In addition to the log chunks, we also labeled search keywords that we would use to search for these chunks within the log. We also sorted the chunks into structural categories. They basically say, could we detect this with the same regular expression? So I brought you two example chunks here from two different build logs. And what we see is that the characters surrounding the two chunks are different. So we would most likely use two different regular expressions to detect this. And that is why these two chunks are in two different structural categories. Now, what can we do with LogChunks? Until now, we have used it to benchmark different techniques that analyze build logs, and we compared how well they work on real-world repositories. And we can use the dataset to train so-called chunk retrieval techniques that are specialized to retrieve chunks from the build log. And with these techniques, we can support other classification techniques that try to decide, is this an environment failure or a developer failure? And the chunk retrieval enables a wide range of automatic processing of build logs. So if we see the failing test is in a certain list of flaky tests, we can rerun the software build automatically. And the benefit of these general chunk retrieval techniques is that we don't rely on the build outputting a specific format that our build tool can work with, but we can just work on the log that is already generated. We can also use these chunk retrieval techniques to create better and broader datasets on software builds and on continuous integration, like the Travis torrent dataset. You can find LogChunks on Zenodo under this URL, and we also included the scripts that we use to collect the logs and our validation data. Thank you for listening.